All right. The question here is to evaluate the definite integral. And this integral is given as such. You have the integral from 0 to 1 of the square root of x squared plus 4 times x dx. Now, we want you to select we have two solutions. And the question is for you to select the correct solution. Explain why your solution is correct. So let's look at these solutions. We have the integral from 0 to 1. So this is solution 1. The integral from 0 to 1 of square root of x squared plus 4 times x dx equals 2. So this person basically used the square root of x squared plus 4 to to basically he or she did the distribution of the square root to x squared and to 4. So this person end up with the square root of x squared plus square root of 4. So the step here was that the person took this. Okay, so uses square root of x squared plus 4 is actually square root of x squared plus square root of 4, which gave you the square root of x squared is x, because x is positive, it's between 0 and 1, and then square root of 4 give you 2, so you end up with x plus 2, and then times x. You then do the distribution, so x times x, and then 2 times x to get x squared plus 2x. Then when you find the antiderivative of x squared, it gives you x cubed over 3. The antiderivative of 2x is basically x squared. So when you get this, then you evaluate those expressions at 1 first. You get 1 cubed over 3 plus 1 square, and then at 0, then you get 0 cubed over 3 plus 0 square, and then you take the difference, you get your final answer. So that's answer 1. Now, is this a correct solution? So we go to the second solution, which again is, we start with the integral. You have the integral from 0 to 1 of x squared plus 4, and then the square root of that, and then times x dx. But this time, this person actually used what we call the substitution rule, and you let x squared plus 4 to be u, and then you take the derivative of that, so you get du equals the derivative of x squared is 2x, so you get 2x dx. Divide both sides by 2 to get 1/2 du equals 2x dx. So then you also change variables in terms of limits of integration. So we're changing x equals 0 to u equals 4, and then x equals 1 becomes u equals 5 using this relation u equals x squared plus 4. So then our integral becomes a new integral, which is the integral from 4 to 5 of square root of u d over 2. But because du 1 over 2 is a constant, so we can actually bring 1 over 2 outside of the integral. So then we end up with integrating u to 1/2 because square root of u can be expressed as a u to 1/2. So you can kind of change that, so you can use the power rule of integration, which give you u to 1/2 plus 1 over 1/2 plus 1, and then times 1 over 2. And then you add your exponents, and you end up with 3/2 as the exponent of u divided by 3 over 2. And then 1/2 So 1 over 2 divided by 3/2 basically becomes 1 over 2 times 2 over 3, which when you cancel out the 2's, you get 1/3. So then you evaluate u at 5 and also at 4 and take then subtract the answer. You get 5 square root of 5 minus 4 square root of 4. Square root of 4 is 2, so 2 times 4 is 8. So you end up with this answer. Now, which one is the correct solution? So make some comments, explain to me why you think your solution is correct. Thank you.